All right, so question 6, scoring guidelines. There were 3 components for part A. The first component indicates the use of a normal distribution with a mean of 300 and a standard deviation of 5. Specifies the correct event, boundary value, and direction. If you drew a picture, because you said that this was a normal distribution, anytime you say normal, you should draw a picture to go with it, because your picture should have the n showing that it's normal, should have your mean and your standard deviation listed and labeled, and it should have the boundary value, and the shading gives direction. So your picture can take care of these first 2 components if you draw a normal curve and you label all the pieces. And then provides the correct probability of 0.5763 or a probability consistent with components 1 and 2. So if you messed up components 1 and 2, but then you did the normal CDF correctly, you can still get component 3. All 3 of those components would give you an E. 2 of those 3 components would give you a P, and 1 or none would give you an I. Please go ahead and score part A. So for 1 and 2, you could write it out, or you could draw the picture. Or your probability notation could take care of this part, but it wouldn't take care of this piece if you had probability notation. Part B has 5 components. I'll have to squeeze to get it all up here. In part BI, indicates the use of a normal or approximately normal distribution and identifies the correct parameter values, the mean of 300 and a standard deviation. Remember, this is for a sample, so it'd be 5 over the square root of 2, 5 over square root of n. So the correct standard deviation is not 5 for the sample, it's 3.5355. And then you have to show work or a correct formula. In part BI, specifies the correct event, boundary value, and direction. Again, a picture would take care of these 2 parts except for the work shown on your standard deviation. In part BI, provides the correct probability of 0.198 or the probability consistent with components 1 and 2. So if you used a standard deviation of 5 here instead of a standard deviation of 5 divided by the square root of 2, your part or your component 3 is going to be something other than 0.198. Yes. Huh? How do you do 5 over root 2? Because it's a sample. If you're talking about 1 member out of a whole population, it's the population standard deviation sigma, which they gave you in the problem. But whenever you're doing a sample, it's the population standard deviation sigma divided by the square root of n. That is true for all your samples. That's why we're practicing this now. Instead of waiting until Thursday, you guys get it in front of you and you forget how to do those pieces. So once they start describing a sample taken from a population, you calculate your standard deviation differently. You have to actually calculate it. Component 4 in part BII indicates whether observing a sample mean of 303 would provide convincing evidence that the population mean is not 300 milligrams, consistent with the response to part BI. So in part BI, if you got the correct probability of 0.198, then we would not have convincing evidence because that is greater than an alpha of 0.05. In part BII, provides justification based on the probability obtained in part BI or a correctly computed probability in part BII. So technically, this is just a one direction. This is greater than 303. But if we wanted to know if it would be just different than 300, you would take that probability times 2 because you would need both tails. Either way, we have something that is greater than any possible alpha value we would have, and so we do not have convincing evidence. All right, so scoring this part, components 1, 4, and 5, and then either component 2 or component 3 would give an E. To get a P, you have to have 3 of the 5 components, or only components 4 and 5, or only component 1 and 1 of the other 4 components. So for an E, you need 1, 4, and 5, and then 1 of these. If you got part 1, you got component 1 and 1 of the others, or you got only 4 and 5, that would be a P. Go ahead and score yourself on this section. Does anybody have any questions about scoring this section? All right, let's go look at part C then. Part C has 5 components. In part CI, you describe the shape as positively skewed or skewed to the right. In part CI, describes the center of the distribution as about 6 milligrams. In part CI, describes the spread of the simulated sample ranges of having most values between 0 and 30. So here it says almost all of the values of the simulated ranges are between 0 and 25, and the center of the distribution is about 6. So those are the first 3 components. Components 4 and 5 have to do with CII, indicates the mean or the center of the distribution of the sample range increases as the population standard deviation increases. In part CII indicates that the variation or the spread of the distribution of the sample range increases as the population standard deviation increases. If you get 4 of those 5 components, then you get an E. If you have 3 of the 5 components, you get a P. Or if you only get components 4 and 5, you get a P. Or if you get components 2 and 4, or 3 and 5. So 3 of these, just 4 and 5, 1 and 4, 2 and 5, I think is what it was, are P's. Otherwise, 4 of the 5 components would get you an E. And that is for part C. All right, let's go score part D. Part D has 5 components. If you get 4 of the 5 components, it's an E. In part DI, indicates a sample range of 10 milligrams is not unusual. In part DI, justifies the response to component 1 by indicating that the graph of the sampling distribution of the sample range when sigma is 5 milligrams shows that values of 10 milligrams or greater occur often. So there are lots of ways that you can make that appeal. They said here, no, a sample range of 10 milligrams is not unusual if the machine is working properly with a standard deviation of 5 milligrams. And then here they're talking about the graph of the sampling distribution for the sample range of sizes 2. You have quite a few. There's about a 20% chance that a random sample of 2 necklaces would yield a 10 milligrams or more. In part DII indicates that there is not convincing evidence that the machine is not working properly. In part DII, justifies the response by indicating that a sample mean of 303 would not be unusual when the machine is working properly, with one of the following. 303 milligrams is less than 1 standard deviation away from 300, or the probability that the mean is greater than or equal to 303 was shown in part B to have a probability of 0.198, which is not unusual, or some other reasonable justification. And then component 5 in part DII justifies the response by indicating that a sample range of 10 milligrams is not unusual when the machine is working properly, as discussed in part DI. So if you get 4 of those 5 components, it's an E. 3 of the 5 components would be a P, or just components 1 and 2, or component 3 and either 4 or 5. Put those components back up here. Go ahead and give yourself an E, a P, or an I, and then give yourself a numerical score. Every E is worth 1 point. Every P is worth ½ point. If you end up on the half points, go ahead and most likely round down. If you have a question about whether you should round up or round down on a ½ point, please have me come and look at it. I'm more than happy to do so. All right. Whew. For the remainder of our class period today, there are 2 different things. One should receive more of your focus than the other one. One of them is flashcards. You're welcome to cut those flashcards out, and then I have little Ziploc baggies over there for you to put your flashcards in. That should not get the main focus of your attention, but it is perfectly fine to do that. I've got big people scissors over there, still a couple more pair. I don't have very many of those, so then I also have little scissors here, if you don't mind having hand cramps for a while. What you need to work on, what you need to spend most of your focus on